Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math basic course, and as always, it is an honor and a privilege to be serving you today, as it is every day here in my virtual classroom. Stepping aside as we jump into section 2.2 in the Big Ideas Math Integrated Math 1 textbook on adding or subtracting to solve linear inequalities. Now, this is just adding or subtracting, no multiplying or dividing, but we do start the solving process same way as we'd solve equations, although we're still going to graph them. Word problems are represented differently. And I think as I start to think about it more, the reason why they're probably separating these by section, this is a short section, by the way, 38 questions, is so that the word problems can come into play. They do want to ease you into it, sure, but I think it's that they just don't want to overstuff it when they do want to do a lot of things in word problems. So we'll see what those look like. We're going to jump ahead to this. If you want to download this PDF, check the description section. You can find it there and find the corresponding timestamps to your problem set as I begin with the lecture portion here. Without further ado, let's go ahead and get started. We're going to solve inequalities using addition and subtraction and solve real life problems with them, everything from before. Core vocabulary, new phrases, equivalent inequalities. That's a mouthful. We'll see what we want to say with it right now. Just as you use the properties of equality to produce equivalent expressions, you can use the properties of inequality to produce equivalent inequalities. Equivalent inequalities are inequalities that have the same solutions. So, the addition property of inequality states that you can add the same thing to both sides of an inequality and it would yield the same result as you had previously. Produces something equivalent. If negative 3 is less than 2, adding 4 to both of these things won't change the fact that 1 is still less than 6. Whatever was on the left is still less than whatever was on the right. Now, negative 3 and negative 10, negative 3 is greater than or equal to negative 10, add 3 to both sides. The left side is still greater than or equal to the right side as that stays equivalent. So they have this in an algebraic form. If A is greater than B, A plus C is greater than B plus C. You can do the same thing to both sides. Do the same thing to both sides. This is like an equation, and therefore we can do solving of algebraic inequalities with them. Looks like they have a graphical visual version of this. If here's A and here's B, A is less than B, you can tell because it's to the left of it. Adding the same amount C to both of these will keep A plus C less than B plus C in that way. Makes a whole bunch of sense there. So adding the same thing to both sides keeps making it work. So if we wanted to solve x minus 6 is greater than or equal to negative 10, for what values of x does this hold true without playing guess and check, trial and error, whatever you want to plug and chug? We can add 6 to both sides. X minus 6 plus 6 gets you just x, and negative 10 plus 6 is negative 4. The values of x that make this statement true are negative 4 and greater than. That includes 0, and I like that they show 0 because, of course, when I graph these on a number line, and remember, this is the solution to the, these are the solutions for x, not for x minus 6, right? It means all of these numbers, including negative 4, can be plugged into the original inequality, and the left side will be greater than or equal to the right side. I like plugging in 0 because what happens when you plug in 0 is 0 minus 6 is just negative 6. You can write 0, but you can also just get rid of that. Is negative 6 greater than or equal to negative 10? You betcha. Anything to the left will not work. Let's try it with subtraction. You can also subtract the same thing from both sides. It'll hold true. They're showing this with numbers as well, and the properties there, and the same way visually. If A is less than B, then subtracting C from both those values, A minus C will stay less than B minus C. Subtracting the same amount, going the same distance over in that direction. So, same thing here. Y plus 8 is less than or equal to 5. We can subtract 8 from both sides. Y will be less than or equal to negative 3. And we can graph that as such. To the left, boundary point is a closed circle. I'm going kind of quickly on that stuff because that's what we were doing in section 2.1, so that's not much more than that. Now on this one here, there's a little bit more work you might want to do, and I'm glad that they're writing the answer. I'll kind of reveal it here. I'm glad that they're actually writing exactly what I would be writing as well. They subtract 1.4 from both sides, and I'm good with that. Minus 1.4, as we should be. They're talking about it. Therefore, negative 9.4 is less than m. But you can see what they did here. They flipped the inequality, the entire thing, the entire statement. So m is on the left side, negative 9.4 is on the right side. Now that makes the inequality itself also flip over. If negative 9.4 is less than m, then m is greater than negative 9.4, which is how we want to compare our numbers to the boundary point. So greater than is now graphed to the right instead of mistaking it for to the left, because that's not what that would mean. Open circle on negative 9.4, graph for m to the right. 0 would be a part of these. Is negative 1.8 less than 1.4 plus 0? Yes, because negative 1.8 is less than 1.4. And again, just plugging in 0 means all the other stuff's going to go away. Solving real life problems. Here's an example modeling with mathematics. A circuit overloads at 1800 watts of electricity, and you plug a microwave oven that uses 1100 watts. Write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit. It doesn't mean you must add the maximum amount to get to 1800. You can add up to an amount for that. So we're going to write and solve an inequality for that. And then in addition to that, which of the following appliances can you plug in without overloading? So we're going to check those with our own inequality that we write. So they're going to use W as the amount of watts here. If you add W to 1100, then we have to make sure that it doesn't. I thought it couldn't exceed 1800. They said it couldn't be 1800. Oh, it says it overloads at 1800 watts. That means even at 1800, no good. So you have to stay less than 1800. Let me clear my throat. Give me 1 second. Okay, I hope I took care of it. So yeah, the watts used by the microwave plus the additional watts has to stay less than the overload wattage. So 1100 plus W is less than 1800. That's our setup. But now we can solve these. Now, we should have been able to before, but now we can solve these. Subtract 1100 from both sides. The amount of additional wattage has to stay under 700 watts as an overall. You can add up to that, which means you can also plug in the clock, radio, and the bender. Oh, we didn't check our blender. The blender. Yeah, I didn't check those ones yet. So anything that's less than 700 here will do. Clock, radio's good. Blender's good. Hot plate is not less than 700. Toaster is not less than 700. Not as long as the microwave oven's plugged in. You cannot plug in those as well. So again, solving for these is something we can do, so we don't have to plug it into a bigger problem and then do that with it. We go straight from there. Sorry, I had to clear my throat again. Okay, hopefully that'll stop. All right. I think that's probably the end of the lecture portion because that was like all we had to do. That is perfect. Okay, that might have been the shortest lecture I've ever done, which hopefully the problem set follows along in a very short way. We start with the vocabulary and core concept check though. Number 1 on vocabulary, why is the inequality x is less than or equal to 6 equivalent to the inequality x minus 5 is less than or equal to 6 minus 5? Because we're using the subtraction property of equality. I don't know if I should type that or write it. Let's see. We're using the subtraction property of equality, where that's what the property states. Whoa. Of inequality, I should say, not equality. You can use that, and the left side will still be less than or equal to the right side, even if you subtract 5 from both of them. Number 2 says compare solving equations using addition with involving what? Using addition with solving inequalities using addition. Compare solving equations using equations using addition versus solving inequalities using addition. Well, the same thing still applies in both cases. The same numbers added to each side, which obtains an equivalent sentence. So in either case, you are adding the same number to each side, which leaves equivalent statements. Whether it's, and I don't want to say equivalent equations because equations for equations and inequalities for inequalities. So that's what I'm going to say for that one. Excuse me. Okay, guys, so we are going to get into the problem set. We go to number 38, I believe. Let me double check that. It is 38 or 39. Yep, I didn't even have the thing pulled up. So it's up to number 38. So away we go. In exercises 3 through 6, tell which number you would add to or subtract from each side of the inequality to solve it. So I guess we're not officially solving. We're just stating which ones you would do. We're going back, folks, to kind of pre-solving these equations using one step. K plus 11 is less than negative 3. If I want to solve this, I'm going to subtract 11 from both sides. They said state which one it is, and that's what we're going to do. Subtract 11 from both sides. It would be the opposite of the addition. Number 4 says v minus 2 is greater than 14. To get v by itself, I'm going to add 2 to both sides. And again, it's both sides of it. They state that, though. They say from each side of the inequality. Number 5. Number 5, I'd love to, well, b minus 9. I'd love to add 9 to both sides in this case. I'd also love to, when I solve for it, I'd love to reverse this whole thing, have b is less than or equal to instead of negative 1 is greater than or equal to. And then number 6, I don't know, these are kind of weird questions. Why don't they just let me solve? Number 6, I have 17 plus p, so negative 6 is less than or equal to 17 plus p. P is a positive number. 17 is a positive number. I got to subtract the 17 over, and then all will be good. Excuse me. Subtract the whole 17. And that's what you'd have to do from each side. Hopefully it's pretty good. Now, they didn't say to solve it, so they just said tell which number. Okay, in exercises 7 through 20, now we solve the inequality. We're going to graph the solution. So on number 7, we have x minus 4 is less than negative 5. As we will add 4 to both sides, so we're going really back to 1.1 stuff, even less so because, I mean, there's the inequality parts as well. A little 1.1 with 2.1, but we're not even multiplying or dividing. We're just adding and subtracting. X is less than negative 1. Now, when I'm going to graph these, again, I'm going to just place 0 and negative 1 on here. Less than will have an open circle, and less than is left. So X is less than. 0 shouldn't work for this. So is 0 minus 4, negative 4 less than negative 5? No, it's not, and it shouldn't be. Therefore, we're good. So remember, when I substitute 0, the variable pretty much goes away. 0 minus 4 is negative 4. In this case, when I plug in 0, 0 minus 8 is negative 8. It's not going to kind of change what's there, so I can just really remove the variable when I substitute 0, which is really nice. Number 8, 1 is less than or equal to s minus 8. If I add 8 to both sides, I'm going to get here, 9 is less than or equal to s, but it's best that you rewrite this so s is on this side. Obviously, you have to flip the inequality when you turn the whole thing over. S is greater than or equal to 9. This will be confirmed when we do our thing with 0 as well. Take a look and see if we did this correctly. If you didn't, obviously you're going to have to redo it. But closed circle, because it's also equal to, greater than is to the right. 0 shouldn't work for this one. Like I said, 0 minus 8 is negative 8. Is 1 less than or equal to negative 8? No. So 0 shouldn't work, neither should anything on that side. Number 9. Again, variable on the right side, so eventually we're going to write it on the left side once we solve it. 6 is greater than or equal to m minus 1. We're adding 1 to both sides, and we get 7 is greater than or equal to m, or m is less than or equal to 7. And just a reminder what we're doing, I'm sure you can tell, but we're trying to find what values of m will maintain the original inequality holding up. If I plug in numbers that are 7 or smaller, then 6 will definitely be greater than or equal to those. If I plug in numbers too big, well, it doesn't work. Now, is 0 a small enough number? Sure, 0 is less than 7. Or equal to it, but it's really less than. Does that work? Is 6 greater than or equal to negative 1? Yes, it is. And there's my double check. You don't have to double check them. I'm just reminding you why I'm plugging 0 in there and how that check works. C minus 12 is greater than negative 4. We will add 12 to both sides, in this case here. And we get C is greater than 12 minus 4, which is 8. 0 is not a part of that. Check that. Negative 12 greater than negative 4. Not so. Remember, larger negative numbers are actually smaller in value than smaller negative numbers. So C, open circle on 8. 8 won't work either because negative 4 ain't greater than negative 4. Only numbers greater than 8 will do. Number 11, r plus 4 is less than 5. Get some subtraction now. So we will subtract 4 from both sides. And here we get r is less than 1. Zero is less than 1. So r includes 0. 0 plus 4 is less than 5. Number 12. Negative 8 is less than or equal to 8 plus y. I will subtract 8 from both sides because that 8 is positive with that y term alongside it. And here I get negative 16, not 0. You can flip-flop this. Y is greater than or equal to negative 16, going a little bit more in the negative direction. But when I draw my graph, it doesn't really matter. Just as long as the number is greater than or equal to negative 16. That includes negative 15, negative 14. Oh, heck, 0, 10. All those numbers will work out. Yep, that'll keep us above water there. Number 13. 9 plus the dubs greater than 7. Subtract 9 from both sides. That'd be a positive number. And 7 minus 9 is a negative number. It's a negative 2. W is greater than negative 2. I apologize if my number lines aren't up to standards by your teacher stuff. If you want to include negative 1 and 1 and such, go ahead. Boom, boom, boom. Make it happen. But I'm just doing these for my good old double checking measures. 0. 9 plus 0 is greater than 7 among anything to the right side. Number 14. What shall we do to both sides here? Looks like a little subtraction of 3. So, I'm going to kind of speak over some problems sometimes when I feel like, it's a little bit more of the same. Otherwise, it adds more monotony to what I'm doing as a whole. And I hope that you can follow along as we do this. Either way, I'm flipping this round, by the way. There's my 12, 15 minus 3. And it's that, again, we did chapter 1 where we solved equations, and remember to the extent that we did them, right? We even did literal equations and absolute value equations and ones with multiple things. And in that first section, I mean, we did multiplication and division. We did decimals and fractions with them as well. All of that was involved. So this goes it goes really elementary with it. It's trying to remind you again for this set that, you can solve these the same ways you can solve equations. And it's trying to get you to still practice your graphing of and what it means for the graph to represent something here. Now, subtracting a negative, I totally want to simplify that to addition before I move forward on the problem. Always simplify your expressions, in which case now I'd love to subtract 2 from both sides. Like so. 10 minus 2 is 8. H is greater than or equal to 8. 0 wouldn't apply there, because 0 is to the left of 8. Is that true? 0 minus negative 2 is 2. 2 is not greater than or equal to 10, so 0 doesn't work alongside those. Number 16. Anyway, so I keep questioning why they broke them apart, and I kind of stated it in the beginning of this thing as a whole, excuse me. I think it's because the word problems. The things they want to do beyond this set, this is good practice and all that. You want to confirm what you're doing is all right. Simplifying here, subtracting 13. But I think they don't want to overstuff in the word problem sense and really want you to focus on one set at a time. So that's where they went with it. When it comes to the quiz review, I think that's where you're going to feel the true combination of what it is we're doing. If negative 19 is greater than t, then t is less than negative 19. Now that goes on the farther negative end. If 0, I'm going to place 0 on the far right over here. I want some negative 19 business over here. And t is less than that. T values are less than that right there. 0 definitely won't work, because 13, 0 plus 13 is definitely not less than negative 6. Number 17, some little bit of simplification. We got to do some combining like terms here. J plus 9 minus 3. Before we were subtracting negatives, now we're subtracting 3's. 9 minus 3 is 6. And now we get to subtract 6 from both sides. So they're keeping it even keel. They're saying, oh yeah, we got to do some of these again, just like equations. J is less than 2. We are supposed to graph these, right? Yep. So J is less than 2. Now again, check 0. 0 plus 9 minus 3 is 6. 6 is less than 8. 0 works as that works out. Number 18. Oh, come on over. There you go. You got it, guy. You got it. 1 minus 12 plus y is greater than or equal to negative 5. 1 minus 12 being negative 11. Now, as y is that positive number, all good there, added with this term, we are going to add 11 to both sides, given that the 11 is negative. We're left with y is greater than or equal to 11 minus 5, which is 6. 0, not a part of that solution. Graphing to the right of this over here. Number 19 and 20 also have combining like terms, but of variables, not of numbers, not of like constants, I should say. And this is on the right side of the inequality, so some work will be had to move it over in a bit. 3p minus 2p. Aha, see, they're still, because they don't want you to do any multiplication or division yet, they need to make sure this turns into 1p. 1p minus 7. Now that we're simplified, we have to add 7 over. Remember, no division yet, not till the next section. No. So 17 greater than or equal to p, or p is less than or equal to 17. Now that we have the variable on the left side of the equation, we know that less than, in this case, means left of, including 0. Because now this is an instance where I get to still substitute into the original. Oh, filled in. This is where I get to substitute into the original equation and really play with this. Again, if I plug 0... If I plug 15 in here, now I got to do 3 times 15 minus 2 times 15, all that. If I plug in 0, I get to do 0 minus 7, just negative 7. And is 10 greater than or equal to negative 7? Yes, any positive is greater than any negative, so that absolutely holds up there. Number 20 looks like it does the same thing when it comes to your variable. because negative 5 plus 6 will end up being 1. So again, there's no division to be had just yet. Save it for the next sections. But a little more simplification. Negative 5z plus 6z is 1z, so 18 plus z, and 3 plus 6 is 9. Now that we're simplified, we can do what it is we were meant to do. Subtraction property of inequality, if that's what they call it. And that's negative 9 that z is greater than. Negative 9 left of 0, but we will graph to negative 9's right. So that boundary value is not included with the open circle. Okay, let's move to numbers 21 to 24, where we write the sentence as an inequality and then solve the inequality. So we did the writing as an inequality in the previous section. We just didn't solve it at the time. These will only involve addition and subtraction, it looks like. A number plus 8, I'm going to use x. A number plus 8 is greater than 11. Is greater than 11. If I subtract 8 from both sides, and they didn't ask us to graph, x would be greater than 3. Now, 0 would not be included in that. 0 plus 8 is not greater than 11. So they didn't ask us to graph, so I'm just leaving it like that. Number 22, a number minus 3 is at least negative 5. So a number minus 3, to be at least negative 5, it must be negative 5 or bigger. So greater than or equal to negative 5. If I add 3 to both sides, we can find out what numbers as such that will make that true. That will be negative 2 or greater. Oh, I got to box that one. X is greater than or equal to negative 2. The difference of a number and 9 is fewer than 4. The fewer than, or is fewer than, is our inequality for is less than. But the difference of a number and 9 is subtracting 9 from that number. It's got to be fewer than 4. So when I take away 9 from it, now you got to have less than $4, whatever it is. So let's add 9 to figure out how much we could have had to begin with before taking that away. Oh, 13. Well, less than 13, right? Less than 13. And finally, number 24, 6 is less than or equal to the sum of a number and 15. Okay. They're making us work. They're making us work. 6 is less than or equal to the sum of a number and 15. Adding a number and 15 together, that sum. We can subtract 15 from both sides here. And 6 minus 15 being negative 9 has to be less than or equal to x. I'm going to still do the rewrite despite the fact that I'm not graphing. It's a great practice to do. Your numbers that you can choose are negative 9 or greater, including 0. Number 25, modeling with mathematics. You're riding a train. Your carry-on bag can weigh no more than 50 pounds. Your bag weighs 38 pounds. Part A, write and solve an inequality that represents how much weight you can add to your bag. So your carry-on can be no more than 50. Your bag currently weighs 38. Let's take the 38 pounds we have, and we can add this many more pounds, but it cannot be more than 50. No more than 50. It can be 50, but it must be less than or equal to it. So that's the right, and they say solve. So subtract 38 from both sides in this case, and this says that the amount of weight that you can still add to your bag is up to 12 pounds, less than or equal to. That'll be our weight. I don't see part B. Oh, this is the one. There was one on another side. That's right. I'm sorry. So this is a part of the same question. Okay, can you add both a 9-pound laptop and a 5-pound pair of boots to your bag without going over the weight limit? Explain. So for part B, 9 plus 5 is 14, and 14 is not less than or equal to 12. So no. No, must be no more than 12 pounds. I mean, my inequality stated that, but I feel like I have to do some writing on that. No, 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 no. No, 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 no. All right. Hopefully that's good. Okay, now I'll move the circle to number 26. You order the hardcover book shown from a website that offers free shipping on books on orders of $25 or more. Write and solve an inequality that represents how much more you must spend to get free shipping. Ah, yes, this is a kind of math thing I might do. So we start with 19. The prices on the bottom with that book is called The Mystery of the Chinese. I can't read that. The Mystery of the Chinese. It might be Ring. I have no idea what that says. Mystery of the Chinese. Oh, Rising? I don't know what that says. I got to get the high quality version of this. Anyway, this costs $19.76. we have to add a certain amount to make sure that we get on orders of $25 or more, our order has to be more than $25 or equal to $25. If I subtract 1976 from both sides, we figure out how much more we have to add to this thing. Let's put that as boom like that. So write and solve, there's the writing of it. Hopefully that's okay. Now my solving of this is, that's 24 cents, and this is now what? $5.24. We have to still add that much as an overall or more, right? You can do $6, that'll work. And that'll be it. All right, numbers 27 and 28, describe and correct the error in solving the inequality or graphing the solution. So on number 27, they have this set up here. Okay, this is good that they have this one, but they have this set up here. They add 14 to both sides. That's what you're writing there. That's why those go away. Negative 17 plus 14 is negative 3, so there's your answer. Now they graph it. They see the less than is left, and they go to the left. The problem is they have the boundary value less than your numbers. That means the boundary value must be less than these, which means you got to flip that thing over. So really, that to me, the mistake, I mean, we know the mistake, but the why of the mistake is really because they see less than is left. They graphed their, they drew their graph in the wrong direction. Their boundary point is correct to being an open circle, and it's the right number. It should be graphed to the right instead of the left. Now, there's some things we can do for that, and I'll explain them out loud, but you could have tested 0 into the original. If I plugged in 0, it would say negative 7 is less than negative 14, and that's true. That means 0 should work as a part of your set. Well, 0 is over here. So you do that. Now, my correction is I'm going to take my negative 3 is less than x. You could test points such as 0. X. You could test points such as 0, which would make it a true statement, but we can also flip over this inequality like that. And when you flip it over, now we can graph here. Flipping it over didn't change my answer. It changes how I know what my answer is going to be, though. See, both of these are the same. Both of these are the same. Boom, 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 boom. But this is the direction we should go. 0 should count. Nothing that side should count. All right, number 28. Negative 10 plus x is greater. What the heck? Well, this is just silly. They added 10 to just one side of this inequality here. So negative 10 is here, and then they just did the plus 10 to make them cancel, but they never added 10 over there. It's just missing. They just said, I'm just going to add 10 and do that. I mean, based off what we know from equations, I think we know better than to make that mistake. I don't anticipate this mistake to happen really quite often at all. I would have rather they made a mistake on not putting an open circle or something like that, or a closed circle. They did not add 10 to both sides of the inequality. Just one side. Ruh-roh. So let's fix that. We have the original problem of negative 10 plus x is greater than or equal to negative 9. I will add 10 to both sides. It's a balancing act. It's the addition property of inequality, y'all. And 10 minus 9 is 1. X is greater than or equal to 1. Now, their graph matches their inequality. So if you were taking a test on this thing, I would hope and imagine that the teacher would be like, all right, you got the wrong answer, but your graph matches your work, therefore I'll still give you graphing credit. You know what I mean? That's kind of what we'd look to do in a situation like that. Okay, number 29 on problem solving. An NHL hockey player has 59 goals so far in a season. So far. What are the possible numbers of additional goals the player can score to match or break the NHL record of 92 goals in a season? If they have 59 goals so far, we need to add X amounts of goals to match or break the 92. So we have to subtract 59 from both sides, and there we will get greater than or equal to, is that 33? 33 or more goals. So that's how many goals they're going to have to do, 33 or more. Good luck. Number 30, making an argument. In an aerial ski competition, you perform 2 acrobatic ski jumps. The scores on the 2 jumps are then added together. So your first score is 119.5, versus your competitor this. They're going to add those. Describe the score you must earn on your second jump to beat your competitor. So when I take my score of 119.5 and add X points to it, to beat my competitor, the score must be greater than my competitor. Not equal to, but greater than. My competitor's score adds 117.1 with 119.8. If I simplify that side, that will be, oh, don't make me do math. That'll make me that 236.9, I believe. And if I subtract 119.5 from both sides, oh, I'm just going like right back to where I was. It was really close to this number. I guess it's going to be 3 more than it, so 117.4. So x has to be greater than 117.4 points. Good luck. Hey, if I just do what I did last time on my aerial ski thing, I get another 119.5, I'll be good, man. Just duplicate your jump or whatever this is. Maybe you're not allowed to do the same thing twice. Maybe that diminishes your score. They did another rodeo McTwist. Oh, that was only part A. Part B. I almost skipped a part. Part B. Your coach says you will beat your competitor if you score 118.4 points. A teammate says you only need 117.5 points. Who's correct? They're both correct. The coach didn't say, they said, hey, get 118.4, you'll be good. Now, I don't know what they're thinking about when they say that. Both are correct. The coach gave a number that is more than 117.4. And a teammate also gave a number that is more than 117.4. Now, when the friend said, the teammate said you only need that amount, see if the coach said that, if they said you only need 118.4 points, I'd probably say now the coach is a little less correct, as in like, no, the teammate's right. I only need the 117.5 because that is just above 117.4. And if that's the next decimal up in order to beat it, then the friend would be more correct. But they didn't say only, and I guess that's the difference. You'll beat your competitor. True. You only need this many. True. All right. Sorry, I kept the circle on number 31 here as I was doing that. Number 31, on reasoning. Which of the following inequalities are equivalent to the inequality x minus b is less than 3, where b is a constant? Justify your answer. This reminds me a bit more of what we do in the chapter test stuff. As long as these things hold up, we're good. So like on part A, and I'm going to kind of use this side for things and then write letters that work out. On part A, it says x minus b minus 3 equals 0. If you notice, a minus 3 was added here and a minus 3 was added here. I guess added is the wrong word to say. Minus 3 was inserted here, so that means I have to insert it there. And 3 minus 3 is 0. So that means that A works as one of your things. I don't know if that's the only one that works, but that one's good. Let's check B. 0 is greater than b minus x plus 3. Okay, this one's a little interesting as far as how things got moved around. If I add b to both sides, I'm going to use a different color here. If I add b to both sides and subtract x from both sides, then would this pan out? Because over here you'd get 0. And here you'd have a 3, which is still positive. Here you'd have this b and this x. So this expression is equivalent to that when it's equal to 0, but it's not equal to. It's either greater than or less than or whatever. Now this one shows a greater than, that shows a less than. Because of this guy right here, it's not b. It's not b. C, I don't know if A is the only answer. C says x, hold on, let's start with this original. X is less than 3 minus b. Now, I don't know how to get to that because if I move b over, I add it over. So it's not going to be C. I'm just going to leave that one out. And then D says negative 3 is less than b minus x. Well, if I change everything, if I subtract 3 over and then add b and subtract x, then I do get, you're going to say everything cancels out. I got to subtract 3 here, subtract x, add b over here, like that. Boom, boom. Everything's switching places, right? Now the 3 is negative. The less than is still there. This is negative x plus b or b minus x. That one does work. So D is also valid. So it looks like there are 2 answers there that you can move things around and make that happen. A and D. A and D. All right, number 32 and 33. Write and solve an inequality to find the possible values of x. Our perimeter must be less than 51.3 inches So when we add 14.2 with 15.5 with x, that must be less than 51.3. 14 plus 2 plus 15.5 is 29.7. When I subtract 29.7 from both sides, I'm going to get an x value that must be less than 21.6, is that right? 21.6 inches. Must be less than it for our perimeter to be under less than that amount. Number 33. Our perimeter here must be less than or equal to 18.7 feet. So on this one, we get to do the sum of these four, 4.9, 4.1, x, and 6.4. I don't have to put feet right there. Leave it. These add to 9 plus 6.4 is 15.4. And when I subtract 15.4 from both sides, I'm going to get, looks like 3.3. X has to be less than or equal to 3.3 feet. If it's within it, we're good. Okay. I think this is the last page. Number 34 on thought-provoking. Write an inequality that has the solution shown in the graph. Describe a real-life situation that can be modeled by the inequality. Well, the inequality is x is less than or equal to 16, but I almost feel like this is something where we're supposed to be doing addition or subtraction with it. So if we did something like, well, let's do something like adding something to both sides. Let's like add 24 to both sides like that. So now it's going to, nothing cancels. This is literally just something you're allowed to do. So x plus 24 is less than or equal to 40. You know, something like that, right? So maybe something like a player, let's see, you have 40, I don't know why I chose 40, now I don't know what to do. You have 40 home runs in a season, and a competitor currently has, you had 40 home runs last season, and a competitor currently has 24 home runs. Okay, I kind of wrote this backwards. I should write 24 plus x, but that's okay. 24 home runs. You don't want them to beat your home run total. Kind of like that, right? Let's swap the 24 and the x so it sounds more like they started with the 24 and they add x amounts. You're fine with them tying you. You don't want them beating you. That's the idea. Okay, number 35, writing. Is it possible to check all the numbers in the solution set of an inequality? When you solve the inequality x minus 11 is greater than or equal to negative 3, which numbers can you check to verify your solution? Explain your reasoning. Well, I mean, not literally you can't check everything because this is an infinite solution set. It doesn't just go on forever. Within any two numbers is a foreverness. So when you see something like x minus 11 is greater than or equal to negative 3, we add 11 to both sides. 11 minus 3 is 8. So x is greater than or equal to 8. No, it's impossible to check every number there. 8, 9, 10, 11, 12, 13, 14, and it goes on forever. But what about 8.5, 8.4, 8.3, 8.2, 8.1, 8.01, 8.001, 8.0001, 8.1234012? You know, it's impossible. There's an infinite number set. So anyway, there's the solution to it. And they said, so let's see, is it possible to? They didn't ask to explain. It's not possible to check every solution. So just check a couple. Just check 0. And so 0 wouldn't work because there is an infinite number. There are infinitely many solutions. Of course. Which numbers can you check to verify your solution? Explain your reasoning. I mean, you can check whatever you want. Now, here's the thing. I would check 0. Check 0. And if anything, a number greater than 8. Like 9, 10, whatever. And a number less than 8. And 8. Now, the only reason... Here's the thing. We've been double checking previously. And Here's part of the thing that I have not been stating at all. We've been previously checking, in equations, the number itself, because it would say x equals 8. So I'd plug in 8, make sure the left side equals the right side. Now we're trying to see numbers that are greater than or less than 8 to make sure we're graphing the right way. What we haven't been doing is trying to see if our boundary point is the right value, if it is or not. That's why you might want to check 8. Not whether 8 is greater than or equal to 8, but whether this was the right number. Or, not 8. Plug in 8. 8 minus 11 is negative 3. Negative 3 on that side, negative 3 on that side. At least you got the right number. Even if it says greater than, whatever. You just want to make sure you got the right number. I like to check 0 because easy calculation. This goes away. Negative 11, not greater than negative 3, so it's not on the side of 0. You can try a number greater than 8, but at that point, I think you're probably pretty good. Okay, number 36. How do you see it? The diagram represents the numbers of students in a school with brown eyes, brown hair, or both. So there's a little bit of overlap on that part. Determine whether the inequality must be true. Explain your reasoning. The brown hair. Now, what I need to know is that brown hair is part of both. I don't think it is. I think it's just exclusively brown hair, exclusively brown eyes. It says H is greater than or equal to E. I don't see any reason that that is actually supposed to be true. You can have more brown-eyed people than brown-hair people. So part A, H greater than E, no. I'm not going to write down the explanations. I'm going to state them. There's no guarantee that you have more brown-hair people than brown-eyed people, or equal numbers or whatever. H greater than or equal to X, yes. This one must be, how do I say? Oh, I'm sorry, that's not B. That's not B. B is over here. Why did they do that? H plus 10 greater than or equal to E. Once again, just because you add 10 more people to the brown-haired set, and it doesn't mean you have to literally add 10 people, but just as a comparison's sake, it doesn't still have to exceed that there. No, there's nothing that states that. Part C, H is greater than or equal to X is a yes. If you have both, that means you have all the brown-haired people and blue-eyed people, plus any additional brown-haired people, or all the both can be, they can both be equal as well. But this is an absolute yes. That must be. D, H plus 10 is greater than or equal to X. Yes. If H itself is already having to be greater than or equal to X, then adding 10 to just one of them will maintain that. That's a mathematical certainty. If C is true, D must be true. On E, H is greater than X. Not necessarily. On this one here, H is greater than X. Now we're thinking about you have to have more brown-haired people than people that have both brown hair and blue eyes. No, every person can have both brown hair and blue eyes. You can have no people who are just exclusively brown-haired and not brown eyes. If I've been saying blue eyes, I apologize. I just saw the eyes thing. I don't know what I'm thinking. Brown eyes. So anyway, everyone who has brown hair can have brown eyes. You don't need something different. So my apologies if I'm saying the wrong thing. Intent has been the same. H plus 10 greater than X? Yeah, at that point, yes, because you can have a tie. This is a case where you can have a tie, but ultimately, you got to break that tie even with one person in addition to that tie. Because you can't have, we already stated this, you can't have less people with brown hair as a whole than you have a total brown hair and brown eyes. Sorry if I've been saying blue eyes. Now I realize I have been saying blue eyes, I think. So that would be a yes in that scenario there. At least in my head, that's what I'm thinking for that one. Okay. Number 37. Write and graph an inequality that represents the numbers that are not solutions of each inequality. What? Write and graph an inequality that represents the numbers that are not solutions. So let's take a look. So for part A, we have x plus 8 is less than 14. If I subtract 8 from both sides, you get x is less than 6. So if x is less than 6, think about everything that is not less than 6. So that would be x is greater than or equal to 6. Now it might help by actually doing the graph first. You think x is less than 6, we're thinking, here's 0, here's 6. We're thinking I would open this circle and go to the left, but now let's do everything else. Everything else is closing the circle, including 6, and everything on this side. So it's everything that's not less than. That would be A. B, hey, we got a decimal, people. We add 12 to both sides like that. 12 plus 15.7 is 17.7. So there's the solution to that set. What's everything that's not greater than or equal to 17.7? It's everything that's less than 17.7. So x is less than 17.7, which would be an open circle to the left of 17.7, which includes 0. That should be 7. So we're going that way on our x's. And I think this is the last question here, number 38. Use the inequalities. C minus 3 is greater than or equal to D. B plus 4 is less than A plus 1. And A minus 2 is less than or equal to D minus 7 to order A, B, C, and D from least to greatest. Interesting. Let's see where we go with this. We have C minus 3 is greater than or equal to D. B plus 4 is less than A plus 1. A minus 2 is less than or equal to D minus 7. Now, you can't really do substitution like you could before because things aren't equal to take place. Otherwise, it gets a little wonky. But we can just do comparisons here. If C minus 3 is still greater than or equal to D, that means in this case that C is greater than D. C is bigger than D. Don't worry about the equal to. If I subtract 3 from C, then maybe it can be equal. Otherwise, it's still bigger than it. That means it's bigger than it. That's for sure. B plus 4 is less than A plus 1. Don't confuse that in thinking that means that B is the bigger number. Well, excuse me, even if this was equal. Even if this was equal, don't be confused in thinking, oh, B plus 4. Plus 4 is bigger than plus 1. No, it means you'd have to add 4 to make it equal to this one when it adds 1. Even when you add 4, it's still less than A's value. That means that A is greater than B in that case. It's still less than A's value all told. Now, A minus 2 is less than or equal to D minus 7. If once you subtract 2 from A, then it could be less than subtracting 7 from D, or equal to. Hold on. Let's say if they were equal to, that means D is the bigger number in that case. That means D is more than A. D is more than A in that case. This might have our order here. If D is more than A, but less than C, and if A is more than B, I think from least to greatest we'd have B. This is kind of a weird question. B would be the least. A would be next because D is more than that, but C is more than D. So I think it's going to be like that then. I think that's it. All right, guys, and that'll do it for this one. This is Mr. Robinson. Thank you so much for watching. The shortest lecture on record I've ever had, and maybe the next ones will be just as short. We'll see what happens. Thank you so much. Take care. I'll see you in the multiplication and multiplying in the multiplying and dividing of inequalities section.